Alrighty, happy Wednesday. Sorry again to have missed you Monday. Hopefully you're all feeling well. Doing a lot better. Haven't had Tylenol in like 36 hours and I'm hanging in there, so that's a good sign, I think. Usually when I go, what is it, 24 hours without a fever? That's what they say about the kids at least. I think that probably applies to adults. I don't know, I do computers, not medicine, so. All right, so we started looking at some of this idea that we can make our code make decisions for us. This idea of branching. So I can have this thing happen, or this thing happen, or maybe this other thing, or some series, this chain of which one of these things should happen based on what particular values are. And this is where code finally starts to get interesting, because we're not just doing the exact same thing from top to bottom every time. We can make different things happen based on either values users are giving us, or calculations that we do, or you can even do some fun things like with what day of the week it is. You can find out what day it is, and you would do a different thing on Monday that you do on Tuesdays, that you do on Wednesdays, that you do on Thursdays, and so on. So once we have this ability to make choices, the world really starts to open up, right? And we can do a lot more with our code. So the last thing we looked at was this membership operator, right? Looking at if a value is in some sort of collection. Now this works with any kind of collection here. So we looked at dictionaries particularly here, because that's a really fun case. So if the key is in the dictionary, we can do something. It's where we got, right? And if it's not in there, well, then we can go and add it if we want it. Again, we're just making this up here. You probably miss having a different instructor, so why don't I teach that class for you? Because I'm not already teaching. That's a joke. I'm sorry. You don't want all my classes. I had that happen once at OCC. A student had 3 of my classes the same semester. I felt so bad for them. Like, oh man, that's, they did all right, but just imagine having me like 3 days in a row for long classes. The jokes get old. That's the problem. Maybe it's funny the first time, and you folks are so kind to laugh at my terrible jokes once, but having to do it 3 times in a row and put on that face, be like, haha, you're funny, Mr. Eric. Yeah, you're funny. No, it doesn't work out well. Okay, so we're going to look more at this membership operator here, this in operator, and look at some other cases we can use it in. Right. So let's go and ask the user to, how about let's come up with a 5-letter word for me. How about that? Ghost. Okay, so our secret word is going to be ghost. And then we'll ask the user to pick a letter. We're just going to do 1 letter at a time here. So we'll say the first letter is an input of enter a letter. So please enter a letter to guess. Okay, and then we can check to see if the letter that they guessed is in the secret word or not. Right, and really we could even check further here. We can say, hey, if the length of the first letter is greater than 1, then we can tell them you don't know how to read directions or something. You can't read directions, can you? Otherwise, then maybe we'll tell them, okay, if that letter is in the secret word or not. So we can say, hey, if the first letter is in the secret word, we'll print that first letter is in the secret word, right? And if it's not, then we can tell them print first letter is not in the secret word. Sure. So this is a nested if-else inside of another else block, which is okay. Right? You can put as many of these as you want. They start to get a little crazy if you have tabbed, tab, 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 and you're taking up half your screen. We might have gone too far. And then there's other ways we can look at doing these later. But for now, it's probably okay. Right? I really want this to be this else. If I wanted to change this, right, and to say I don't want this to have to be tabbed in so far, we could change it. Right? This will definitely get the job done, and there's nothing wrong with this. But if you wanted to do it differently, we have options, and that's when we start looking at some of these logical operators. Right? Remember the McDonald's fries are gross. You never say you want fries. When they say you want a burger and fries, you always say, ew, no, because their fries are terrible. Right? Now, or, yeah, I'm vegetarian now, but I used to like their quarter pound burgers, because they promised they are cooked fresh. If you've worked at McDonald's, you know otherwise, please don't ruin that for me. Right? I want to believe that they're cooked fresh on demand because that makes so much better of a burger. If they actually cook that patty fresh rather than it's been sitting in the warming tray for up to the amount of time that the health department says is safe, and then probably beyond that, because let's be honest, no one's checking on them. I like to order the fresh food, so I think that's probably a safer bet. All right, so if we wanted to change this here, so I'm going to leave it here, but let's rewrite this then without the if-else inside of the else here. So we could say if the length of the first letter is equal to 1 and the first letter is in the secret word. Right? This can be one case here. We're going to check both these things must be true if we're anding them together. So if you entered one letter and it's in the secret word, let's go for it. Now I can tell you that's in the secret word. Then I can check else if the length is greater than 1. Sure, I guess. We can print you can't read directions. And then just an else. Print is not in the secret word. I'm not really a fan of this order here, so I do want to change this. I want to keep that same order. So let's do this one first. Now, we don't actually need, that was length of first letter is 1 here. If we put them together like this, we don't actually need to be checking the length right now, because if it is more than 1, this else if is never checked. Remember, once we start putting these things together in the grouping in a chain of them, they become mutually exclusive. The first one that runs, and the rest of them are ignored. So if I check for this first, then I don't need to check for it again later on here. So it's actually making this a little easier for me here to say, okay, well, if it's not more than 1, it is either 1, I guess it could be 0, but if it's 0, it's definitely not in the word anyway, so it's probably okay. Or if we wanted to check for that, we could do that. So this is going to be here. Oh, I put that in the wrong spot. There we go. Can't read directions. Is in the secret word. Oh my goodness, we'll get this right. Just have to copy paste. Okay, so if it's more than 1, you can't read directions. If it's not more than 1, is it in the secret word? Okay, it is there. Otherwise, it's not in the secret word. If we wanted to also check for empty, we could do that here too. And maybe this is a good thing, because sometimes you hit enter when you don't really mean to, and then you have an empty input. That's just fine. So we can say if the length is greater than 1, or the length of first letter is 0. Right? We could do that together. So if either of these is true, either the length is 0 or it's more than 1. Right? We can't. That's not a range that we can check. Right? Like sometimes we could sandwich. We could say, hey, is it greater than 3 but less than 5? We could sandwich that all together here. There's no range happening here because it's two different. It's either 0 or more than 1. Right? So we could just do it with an or. So if either one of these is true, then the whole thing is true. We'll tell them they can't read directions. Right? So it does the exact same thing, but maybe it's a little simpler than this. Maybe not. Hector, my friend, thank you so much for donating some bits to the Student Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. This is my 3rd cup of coffee for the day, and it's only noon. And by cup, I mean, this is obviously larger than 8 ounces, which apparently they measure coffee in 6-ounce cups, which upsets me. So, like, if you get just a regular cup of coffee, it's like 6 ounces, and I don't know why. I feel like they're cheating, which is no fun. But that's okay. So I will go get more coffee later as well. I'm very excited. I'm going to meet one of my colleagues for coffee, and they're also an afternoon coffee drinker, which they must be a good person. I've never met them before. They're new. And I was like, do you drink coffee in the afternoon? They're like, yes. They're like, you're my kind of person. So I was very excited. Yeah, there's a lot of really smart people here, which is really neat. I can meet all sorts of really cool people in this department. I'm going to pour coffee all over my lap, and it's going to be sad. Okay, so both of these are equivalent, right? I guess we didn't check for 0 here, right? We could add that check for 0 here. So I guess we gained a little bit here checking for 0. But other than that, does the same thing. Right? But now we have them in a chain, and generally this would be preferred. It does the exact same thing. Again, if it works, it works. You get the points here. But if we can avoid having to put a bunch of stuff inside, it's probably better, right? And it works out, right? Either this one will run, or this one will run, or this one will run. We just kind of have, really, this could just be an elif then, right? Here, elif, and then we're done. That's all we really changed here, right? It just became an elif. It was just another one of these cases here. Okay, so we can ask them for one letter, right? We can see if that's inside of it here. So when you check for membership in a string, works the same way. Is this letter in the string? Now, if I didn't check for the length, they could enter a longer string, right? And what they're going to be checking for is that exact string inside of the other string. So sometimes we call those substrings, like this portion of a string. So do you have ABC inside of the larger string? And you'd look for that particular sequence of ABC rather than one letter. So letters make sense a little easier here, but you can do longer words here. So I could say, hey, if what do we want, like OST is in the secret word, contains OST, something like that, right? It works just the same, but it's going to look for that particular sequence of OST. So if I put backwards here, if I did TSO, it's not going to match. So it doesn't say, is this letter in it, is this letter in it, and this letter's in it? It's looking for the entire sequence matching here. So OST is in it here. It was great. So you can check, does this belong in the other one with this membership operator? Gives us lots of options. Okay. So, and if we wanted to now, we could repeat this a couple times here, ask for more letters, and they could hangman style play a game, right? Sort of. We don't really have a good way of printing out the blanks here. We could, be a little tricky. Once we get to next week, we'll actually be able to write hangman. That's a fun little game to play. We just don't have a good way of doing that quite yet. Okay. So checking inside of strings, because they're just like another sequence or another collection, a sequence type, like a list or like a tuple. Okay. When you check inside of dictionaries, we're checking keys. We can check for lists. I think we did lists first, and then we changed it to a dictionary, right? Did we do that? Or if we had like my kids, see if have a list of kids. Joy, Phoebe, Journey, Jubilee, Jackson, Jasper, and then I can ask for a name. So name is input of enter a J name. So I guess I should fix Phoebe then, because she is a Genevieve with a J. It has a J, right? It sounds like a J. I think, is it French? Is that where that one comes from? I feel like we steal all sorts of names. And then if name is in my list of kids, you can print you have the same as one of Eric's kids. Print that's a unique J name. Something, right? If that name is in this collection list here, or a tuple, right? I'm not going to change the list, so it could be a tuple. Most of the time I default to lists because it's just easier, and I never remember to do the parentheses. So we'll, we wanted to see our secret word work first, right? So let's get the first letter, and we should get the same answer twice here when we run this one. So what letter should we guess? An R. R is not in the secret word, right? So our code works, best we can tell. Now we haven't tried all of the other things yet. So if we wrote code and we haven't tried to see if that part works yet, we probably don't have a good level of confidence that it does what it's supposed to do, right? The idea that we want to write code and make sure it works is that we're going to test it. We're going to try it. I want to make sure I can get each one of these results here as we go. So if we rerun it, not the whole thing, that was wrong. I want just this portion here. So let's try and pick a letter that is in the secret word. What letter should we pick? S. We get S is in the secret word. Okay, so two out of 3. Now let's try one more time, and let's give it something longer than 1 here, or 0. want to try 0 or do you want to try more than 1? 0. All right, we just hit enter. So the first one says blank is in the secret word. Uh-oh. Empty is in the secret word. So the first case didn't work for us. So the second case is catching it, that we can't read directions. So apparently an empty string is in the secret word. That's interesting. If in secret word you have an empty string, let's run that. Look at that. So it's not really doing what we want here. It's not a good case. So it's good that we added this check for length of 0. Right? And this is why we try it, because I'm going to pretend like that was on purpose to illustrate this, but I didn't remember that it did that at all. So now we know. Right? So this is why we try our code. Right? We write the code and we test it. Does it do what we expect it to do? Because I know for a given input what I expect to have come back out. When we're writing programs, if we can't do that, if we can't say, I give you this, this comes out, we don't really understand what our program's doing then. Right? If you can't illustrate that just thinking through it in English, we're not going to be able to write the code for it, because if you don't know what it's supposed to do, you can't make the computer do magic. Right? They're not actually magic boxes, believe it or not. They only do what people tell them to do. And unlike our friend, the Google engineer, the computer is not sentient. He's nonsense, man. If you train a computer to respond to questions, and some of the stuff that it trains on, like is supposed to ask these philosophical questions, you think it might answer like that because you told it to? Yeah, it's going to do that. It doesn't actually understand any of it. It's just a computer. Just a computer, friend. I don't understand why that guy went off the deep end at Google, but that's okay. That's another story for later. All right, so we know this seems to be working here, so we'll try the next one here. So we'll try and see if we can get a name in the list. All right, so what JName do you want? Let's see if we try one that's in the list, try one that's not in the list. Joe. That's a unique JName. That's actually not a very unique JName, is it? Bummer. But unique to me, at least. I don't have a Joe. All right, let's try it again. Well, I'll run it and pick one of my kids. Jeb. It's Jeb's birthday today. Happy birthday, Jeb. 15. She's crazy. And we have the same name as one of Eric's kids. So cool. So we can check for lists, we can check for dictionaries, we can check for strings inside of strings. We got lots of options when we use that membership operator. It's really powerful and very handy to check this sort of stuff as well. Yeah, let's make sure we're not missing anything here in our branching chapter. We did if else, equal values, ranges with gaps, features, yep. Data types, membership. We didn't do the identity operator. The identity operator is really weird here. The idea with the identity operator, you can also use not in. Right? The not is the opposite. So not in means if it is in, flipped. Right? Not in. So it works the same as in. Substrings. This is identity operator. Is really weird because behind the scenes, Python keeps track of what objects are. I think we looked at real briefly the first chapter. You can get the ID of anything. You can get the ID, the type of anything, and then the the value of anything? I'd have to go back to chapter 1 because I don't remember. So if two things have the same ID, they're the same value. And then the is operator, the identity operator will be true because they are the same thing. So if we were to store, this doesn't always work super well because some stuff happens behind the scenes, but we can try it here. So we'll say test value is 10, and then other value is 2 times 5. Let's just print the ID of the test value, and we'll print the ID of the other value. So they both should be 10, right? Because 2 times 5 we know is 10. Not super hard arithmetic here. So the ID behind the scenes is the same. Python is sort of cheating here and saying, hey, I don't need to store 10 again, right? Because I already have 10 stored once. So other value and test value, if I use the is, the identity operator, are going to say, yes, they're the same thing. So if I were to change this, we say starts at 2 and then take other value plus 8. Let's try that. Oops, right click. There we go. Did it run? Still the same value. Is it running? So let's try printing it here, where they're not the same value. Now they're different. There's 2 different values are stored in memory somewhere. So now if I take other value plus 8, let's see if we can print them out again. So we add 2, it's like, oh, hey, now you have the same value. It's kind of cheating here. Python does some really cool stuff behind the scenes to be fast, right? If we don't, now this is not very interesting with just 2 integers that just take 4 bytes each. But imagine we have gazillions of these things. It would save a lot of memory if instead of having a gazillion integers in memory, we just have the one and they all just use that value. So it does some cool stuff behind the scenes. No, not that one. So is a cool operator, not the most common here. Like if X is Y, right, the IDs match, essentially showing us. You can do some fun stuff with it. Later on, when we get to more complex code, the is will be a little bit more interesting. Right now, it's not the most interesting thing here. But most of the time, we just want to use our equals anyway, because that is a little easier for us to check a value. If we want the values to be equivalent, not do you point to the same location in memory. It's not the most interesting one. Let's try these with 2 lists here. So we'll print. We'll make a list. So this is first is going to be 1, 2, 3, and last is 7, 8, 9. We can print the ID of first and print the ID of last. Oh, I want spaces. The yellow lines aren't errors. They irritate me, so I will generally try and get rid of them. Sorry. Now there are 2 different lists in memory, right? 2 different IDs here. I say last equals 1, 2, and 3. I print them again. Still different. So it's not doing that same shortcut like it did with regular integers behind the scenes. But if I say, oops, where's that parenthesis? Last equals the first here, and then I print the IDs out. Now they do match. As I said, oh, they equal here. Now, once you set a list equal to a list here, and if I were to print first contents first and print last contents and last, and then first append, let's add a 42, and we'll print the contents again. It gets added to both. Oops, sorry, I tried to zoom in there. Because if you say this list equals this list, Python says, oh, sure, first and last point to the same location in memory. They are the same list. It doesn't make a copy of this one and put it somewhere else. But we can see when those IDs match, I don't have a copy. I have first and last both point to that same location in memory, is what's happening with these. So got to be a little careful with lists here. There's a way to make copies of them. It's actually really quick, but we'll get to that in the lists chapter. But this is where that is could be useful. You can say, hey, is this list this list? Right? I don't want to check are their contents equal. I want to check are they literally the same list, and that could be useful at that point. So some fun stuff with checking those there. Okay. All right. How are we doing the rest of the chapter? Order of evaluation. This is the one I skipped over because I couldn't remember which one goes first. Right? Our regular order of operations, parentheses, arithmetic operations, then these relational equality operators. So we're going to check for less than's, greater than's, which I think makes a lot of sense. So when we look at our single click, come on, I think my mouse is too sensitive. When we looked at these relational operators, right, I think it makes sense that these would happen first, because otherwise I have one or length. Right? If the logical operators happen first, we'd get some really weird nonsense. Right? If I said one or length happened first, that just would be super weird. So the relational operators first to get those Boolean results, then the logical operators, and they actually have their own sequence here. So you want to be careful when you're doing your logical operators here. And I think a couple people ran into this in the lab, right, on Monday. I had a couple questions. That was Monday? Wow, that was 2 days ago. That was like a blur. Where ands happen first and then the ors happen. So when people were saying, hey, I want this and this or this, right? We said if the computer was rock and if the player was rock and the computer was paper, or what else? Who else beats rock? Paper beats rock. I can't remember now. All right. Spock beats the rock. He vaporizes the rock. Is that what that is? So if you were to say in your code, oh my goodness, single click. I think it's my mouse here. So we said, player was equal to rock and computer is equal to paper, or computer equals Spock. If we don't force this order of operations, the and is going to happen first, then the or, which is not what you want to have happen, because then no matter what, if the computer was Spock, the whole thing will be true. And we'll get some weird results. So hopefully you played your game and we tried it and you were like, why does the computer keep winning here? They shouldn't be winning. Right? And that's not the kind of thing we'll notice until we're actually running the code, trying these things out, trying the different options here. So to force the order of operations, we just throw some parentheses in. Right? To say, okay, this one or this one first, tell me true or false. Then I'll and that with my player here. Right? Okay, cool. I remember Monday. Vaguely, really vaguely here. Say player equals, we'll do rock. Computer equals Spock. There, now this code won't complain too much. Yellow lines kill me. Okay, so this is for, I think it is my mouse, it's not like single clicking. Order of operations is important for logical operators. So anytime I would just add the parentheses. Even if you want the and to happen first, like that's intentional, I would still put the parentheses in, because remember, the code's for people. You want to be able to see what's supposed to happen without having to remember, oh wait, do ands come first or do ors come first? Because that's not the kind of thing you should have to remember. It's not worth your brain power, right? So if you want one of them to happen first, put the parentheses in, even if it will do the right thing. Okay? Had another one of those obnoxious order of operations questions on Twitter, and I like to argue with people online because apparently I'm like a boomer too. But it's like there's this engineering feed that has all sorts of fun engineering stuff, and they're like, well, what's the answer to this problem here? And they had, was it 6 divided by 2 times 2 plus 1? They're like, pick what the answer is. Is it 9 or is it 1, or other nonsense? And people are arguing online, as people like to do, because we have nothing better to do with our lives apparently. And like, yes, this is implied multiplication. Math people are just lazy for not putting in the star, right, the multiplication sign. And someone was like, hey, I plugged it in the calculator and I got one answer. It's like, well, your calculator's dumb. But turns out Wolfram Alpha doesn't even allow this notation. Like if you try and put it into one of these online calculators here, Wolfram Alpha, if you say 6 divided by, it's like, oh, hey, you now go under the sign to avoid any of the ambiguity, right? You don't get an inline division sign and then we don't know what's under the division sign or not, right? So if we just use proper notation, we don't have to argue with people online. So it's like, okay, inconclusive, I guess. But the answer is 9. We know order of operations here, right? This is just a multiplication sign. It's all it is. They go left to right. I mentioned something about crying about our education system and why people don't understand how this works. But order of operations is important, friends. It saves lives. So does the Oxford comma. Don't eat grandma. You've all seen that one? I guess that's not order of operations. That's just commas, but grammar saves lives, I guess. My mouse is not working. This is going to be no fun. So these are all good. The not happens first when we look at the logical operators, which is good. This does not work well here. So if we wanted here, this might even be easier. Instead of doing this or this, we could say if the length of my first letter not equal 1, well, you can't do it this direction. It doesn't really work exactly like English, but we can say not length equal 1 here if you want. Or you can also, because this equality operator here has another one, I don't know if we looked at this one yet here, you can say exclamation point equals here does not equal 1. So this is a not equals operator here. This is not equal. So instead of having to say not and then use the equal sign, it saves us time because this is a common thing we check for a lot. If it's not this, do something. And then now this is even simpler than saying, hey, if the length 0 or the length is more than 1. Right? If it's not 1, you screwed up. Okay, so the not equals is nice here, and then it's part of that equality expression, which will be single click right in here with our relational operators, as well as in. Okay, so order operations is important. This is like going through some of these examples is fun, seeing which one happens first. I do like the Zybooks. Sorry, the price has gone up a little bit now that they got bought by a real publisher, but overall, I think it's pretty good. If you hate it, let me know, like in the course feedback at the end of the semester. And you can tell me now too, but at the end, my department chair has to read all these evals as part of my evaluation process. So if I can say, hey, the students all hate this or the students all like this, it's easier to make changes. Okay, so order of operations was good. The indentation is really tough. Right? Everything has to be tabbed in, and that's where it's going to get upset with you if it doesn't match right. So PyCharm is pretty helpful. Like if I just enter down, it's going to automatically tab stuff for me. If I enter again, it's going to stay in that tab here so that it all belongs to those blocks. But if I want to do spaces myself, I can, and it's okay with that, but it doesn't line up. It's bad form to have it not line up. Now, Python doesn't care, but I can't have different alignments in the same code block. So if I have 2 spaces here and I have 4 spaces here, Python's upset with me, and the little red line here says this unexpected indent. So if you see unexpected indent, you either didn't add the colon or it doesn't match some of the other indentations. Not the most helpful error in the world, but the problem is with the indentation at that point. So if you line them all up, now life is good. And then if you like shortcuts, you can grab more than one line and tab them at the same time, or shift tab to bring them back. If you like keyboard shortcuts. A lot of times I'll tab or shift tab things. That's just little keyboard shortcuts. Okay, so do be careful with your indentations, especially when you start having these nested ones, right? Stuff inside of that we mentioned, you can get way far into the middle of the screen here, which is just, it's not the prettiest. There's nothing wrong with it. It just gets a little busy on the eyes here. So the indentation is important. The conditional expressions. Do we do the conditional expressions? This like the single line. I feel like we did that, didn't we? Did we not? This one, this conditional expression. Okay, I threw it in the middle because that's confusing. Sorry. A lot of people who do Python are really big fans of these. So it's awkward. It's going to feel real funny, but you'll see these a lot for simple cases like, hey, it's either this value or this value. You can do that. Now, if you want to get gross, you can also do another conditional inside of a conditional. I really don't recommend that. But some people think it's cute and they're like, hey, look, I can make Python do funny things. So we could throw another one inside of here. So fail if score is less than 60, else D or something like that. And at this point, I have no idea what's going on, right? It just, okay, this one is the else case of this one here. Sure, it's just, let's just not do the ugly things, okay? Perfectly valid code would definitely work. I don't recommend it. So usually the conditionals are one or two. If you need a third choice, just use if-else-ifs, and life will be a lot easier for you because everyone else will be able to read it without getting their eyes crossed. Okay, but you can use conditionals if you like them. One funny story, just because it's entertaining. These statements you can do in other languages as well. And one class that I taught where I had 7 people cheat on the final exam, I caught them because they used conditional statements that they found online. We had never done it in class before because I hate them. I was like, they exist, I'm never going to use them. And all 7 of them had the exact same conditional statement in their code. Made me real suspicious. And then I had to spend time and go Google things and found they all used the same source online and didn't cite their source. So, that's just, if this is not a common practice, don't copy paste it without citing your source. Just make life easy for you, please. I don't like failing people. It's really a lot of paperwork, and I'm like allergic to paperwork because there are so many better things I could be doing with my time than filling out paperwork. Okay. Yeah, I think we're in pretty good shape here then. Data types. This is the other common errors here where we run into trouble trying to compare things. Case sensitivity here in strings matters if we're checking. So anytime we're dealing with strings, I guess we'll just throw this down at the bottom here. Sorry, there's a parenthesis there. So if I want to say, hey, if A is in apple, it's not going to be in there because it's case sensitive. So if we're dealing with some user input, right? So we'll ask I guess we had that ghost example. We'll go up higher. So if I want to ignore case when I'm comparing things, probably the easiest way to do that is when I get their input, there's an option to turn their input into something that's lowercase or uppercase. So if I know my secret word is all in lowercase, when I grab their input, I can say .lower. So I can input and then use this .lower will lowercase everything that they've typed in. So if you are getting their input and need to check against other strings, .lower or .upper. So lower for lowercase, .upper for uppercase. Whichever you're using, probably stick to that. Otherwise, we'd have to check the uppercase and the lowercase version. And we could do that, right? We could say, hey, if, yes, ours would have to be secret word uppercase ghost, which is kind of messy. We could say if the first letter is in my secret word or the first letter is in the secret word uppercase. And hopefully just looking at that, you're like, oh, this is awful. I don't want to have to do this every single time, right? So if we're dealing with user input, just force it to be upper or lowercase. And then we can check really easily here. You checked the hard way for case, right? Not the easiest way here. If you don't want to change what their input is, you can say first letter dot lower like inside of the checks here. If you're going to check it more than once, though, you might as well just change it the first time, because otherwise you have to type dot lower a bunch of times, and then it's easy to forget one of those times here. So usually doing it right on the input is easiest. And you can do it in line, but it gets messy. Or we could say first letter dot upper, right? Let's check the lowercase and we'll check the uppercase. You need the room here. That's just ugly. But we could. So casing is important. We can't compare numeric values less than or equal to strings, but strings we can compare to strings. We can do that, right? So we can say, hey, if CIS is less than Eric, print Eric is better than CIS, or something, right? And it will totally compare these. Did we talk about this one before? Comparing strings? So remember we looked at the Unicode values of strings? What we compare then is the Unicode value of characters in the first one to the first one, the second one to the second one, the third one to the third one. So a capital C is less than a capital E because the Unicode value is less here. So we'll see that Eric is definitely greater than CIS here. I guess better is maybe not the right term just because I'm greater than, but I can imagine, right? How about greater? So when you compare strings, you can do these, but it's not very useful most of the time. Like, what does it matter if this string is less than this string? For sorting, that's useful. If I wanted to sort things alphabetically, we could sort them using these sort of, here's the least string, right? The smallest string, we could do that, sure. So with the list of names here, let's print Eric's minimum kid is min of kids. And where did the rest of that go? Up there. My minimum kid is Jackson, because he's JA, right? So A is the lowest value. So all the J's are the same. So then they look at the second letter. So JA, well, there is Jasper also is JA. So that one matches, but then it's going to look at the third letter. So C versus S. So C is less than S. So you can do minimum, you can do maximum. You can't sum strings, though. That doesn't work very well, unless we're doing our silly gematria or whatever that nonsense was lab. Right? We could come up with sums of strings, but they're meaningless. But you can sort, essentially. You can get the minimum with strings, which is kind of fun. Same with lists, too. You can take two lists and see if a list is less than another list. It's going to look at the first value, check greater than or less than. Look at the next value, check greater than or less than. Look at the next value, on and on and on. So we can figure out which list is the smallest as we go. If you only use a single equal sign, bad stuff happens. Okay, so my favorite number is 42, and then if number is equal to 42, and you have the answer, something like that. But if you miss your equal sign, your second equal sign, it gives you a colon expected, which is not the most helpful error here. Right? Like, what do you mean a colon's expected? I have a colon right here. But what really happened is this is not an expression here. So another fun thing about Python is the technical term for it is truthy. So I could just say if number. So any variables in Python will automatically be true or false. Numeric values, if they're 0, are false. Anything other than 0 is true. I don't know why, but that's just how it works. So you can just say if number. So if you're not careful, not really paying attention to what's happening here, this just works. And that's why it was saying it was expecting a colon, because this equals 42 was ignoring and saying, hey, you should have just had a colon after number. That's why it tells us the colon was missing. So you can say that. It's perfectly fine. So if it's 0, right, this won't be true. Anything other than 0, it is true. And then for strings here, so we have like some word is test. We can say if word, it's not false. It works just fine, which is really weird, but we're essentially saying it has a value. So if the string is empty, so if word is an empty string, and then we check it here, nothing happened, right? Because an empty string is false. Empty string is false. Non-empty string is true. So if there's any characters in your string, it's true. This is non-zero numbers are true. Ooh. Hey, my friend, Y Paladin joined on Twitch. Glad to have you along. Awesome tech friend out in California. I think it's California, right? All right. How are you folks feeling so far? It's a lot, right? We practiced some. We're doing a little more today. We're moving along. We got a lot of content as we're working through here. We're back on track where we want to with branching here. I don't really want to start loops yet. I think we'll be okay to do those next week here. Our labs are like halfway. That should be okay. So we'll start it. We'll start practicing lab, and then we'll finish it. I think that'll be okay. Is that a question? Yeah. No. So we need the branching for the project. So, and thank you for asking about the project. As you saw, I wrote this myself. So if it doesn't make sense to you, I'm sure it doesn't make sense to someone else. So if it's unclear, like what this particular part I'm supposed to mean is here, right? Ask. And then everyone else will hear the answer and be thankful because they were too shy to ask or for whatever reason here. So this if part we need, this idea. So if I don't have enough money, is the stuff we were covering this week with the branching. I can say, hey, how much money do you have? Is that more or less than this? How much you want to buy here, right? And do either yes or no from here, from there. Oh my goodness. Right, same idea with if we don't have enough quantity in the dictionary. You wanted to buy 12 packs of ramen noodles and I'm down to 5. I can't sell you 12, right? We tell you no. So this the same idea. So the code will have to make choices based on that. Oh yeah, thank you. So Paladin says, asking questions is good practice to get into. The real world will save you plenty of time when you're coding to ask those business questions. A lot of times when we're asked to code things, they say, go do it. And they know how it all works because they actually do all those business functions. And unless you have done that work, it's really hard to know what they mean sometimes. So clarifying is very important, definitely. Okay, so hopefully this is going well. You've all started it, I hope, because it's due next week at 12:30. Yeah. Oh, it's supposed to have a rubric. Yeah, thank you. I didn't add it. Let's add a rubric here. So this is project 0. Oh, I did. Yeah, it's okay. That's right. It has a rubric, but it's not attached, right? Is that what it was? Rubrics. Yep. Oh, you can't see the rubric though. Okay, hang on. Let me go to change the settings here. Navigation. Where did rubrics go? This one here. I don't know how to make it attached now, and I'm super confused. That's what happened, is I just got a big dumb and didn't know what was happening. All right, so you should be able to see the rubric here, but I don't know how to make it attach to the actual project. So this is the rubric, right? So for the different parts, 2 points for each. If it works, great. If it doesn't work, no points. If it sort of works, feel free to give yourself some partial credit. So when you do turn it in here, I didn't even ask for it. Ideally, you look at it and you score yourself. Like that's why we have the rubric, so you know how you did on it, and that's your last chance to make sure we got all the different points off each place. And find a rubric. Okay. Wow, that's way too many of these here. Which one is ours? 202310. 202310. This one here. It worked. I'm amazed by simple things. Imagine the technology works and does what it's supposed to do. Okay, so now you should be able to see that rubric in the assignment there, I think. Fantastic. So if you don't see it there, let me know. But now it's attached. Thank you for asking that. We found the magic buttons to click there. Okay. Again, I'm sorry. Yeah. What chapter was dictionaries? So dictionaries was all in chapter 3 on types. This was our types here, so you can look at some dictionary basics here for chapter 3. Yep. So due next week, first thing I'm going to do in class that day is go over my solution to it. So I can't take it late. So please start early, ask me questions early. Happy to help with you, point you in the right direction. Literally, they pay me to answer your questions. Otherwise, you could just go watch YouTube videos. Right? Like, what's the point? Well, I guess I get paid to give you a grade too, because that's the other important part, is you need grades. Higher ed's not a racket, I promise. Yeah, sorry. It's kind of funny. No, because, okay, sorry. Yeah, ask me questions. Again, work for a good half hour, hour on it. Try and get yourself unstuck, and then come ask me. I'm happy to point you in the right direction. I'm not going to tell you to go away. But if everyone does that and waits until the 27th at like 10 p.m. and they're like, hey, Eric, I need some help, I can help maybe a couple people. I'll try, but it's not going to go very well if everyone waits till the last minute. So don't be like me. Do what I say, not what I do. Don't wait for the last minute. Work ahead. Just start small little chunks, right? You could like tackle just part one and get that done and working, right? Okay, wait, let's make a dictionary. Fantastic. And then part two, okay, let's just ask them 5 times to buy items. Great, we've got that. And then we'll do the next. You just tackle it little bit by little bit by little bit. You don't have to sit down and get the whole thing done all in one sitting, right? We can do small pieces, small parts, a little bit at a time. So if you don't do the quantity checking, don't do it yet. That's fine. We can add that in after. Right? We can go through and modify it. Most expensive item, total, how much money you have left for your receipt, that sort of thing. And then showing the dictionary at the very end. It's pretty quick too. Right? You just print the dictionary. It's like 2 points for that, just for print dictionary. Right? That shows your quantities and everything. When you print a dictionary. Okay. So it shouldn't be too bad, I hope. And just some practice, we're easing into it. They'll get slightly more interesting as we go. Again, it's our first semester coding, or it's expected to be your first semester coding, so we're not going to do anything super amazing. I apologize, but we'll take some small projects and go and work on building some practice, building our skills here, working through this. Okay. All right, any other thoughts, questions, or concerns? Cool. I think we're in pretty good shape then. We'll call it a day today. Oh, how do you get one specific value out of a dictionary? So if you have 2 values for one key, so that's kind of how you design the dictionary. Remember, because a dictionary can only have one associated value, but if that associated value is another either dictionary or list or tuple, probably not a tuple because you want to be able to change these things, we can do that. So I can have, if I had classes is a dictionary, and then I can say classes key of CIS 1501, and I can associate a value of another dictionary if I wanted. And I can say classes key of CIS 1501, and then that will get this dictionary I've created. I can add another key of something like meeting time and say this is Monday, Wednesday, 12:30 p.m. to 1:45 p.m. Right, we'll get the meeting time value associated with the CIS 1501 value. Right? The dictionary of dictionaries is one way of going about it here. Right? The other way, if you wanted classes list, we could say is a dictionary, and then instead of assigning a dictionary, I can just assign a list here, and then in that list I can say, hey, I'm going to append the first value. And I just have to know that index 0 is going to be the meeting time. It works. It's a little trickier, has a little bit more of a mental load, remembering, okay, the first index is something else, and then maybe the next index then could be, I don't know, what do we want to say? Python programming, or I don't know, anything else we wanted to add in here, right? So maybe this could be like a description. It's okay, sorry, it's not. This is CS1 for data scientists. Sure, we can make that more official. Oops, too many quotes. Right, so I like dictionaries because you have a named key here. If you just want the first thing is this, the second thing is this, that works too. It's just going to be maybe perhaps a little harder on remembering which one's which. But they both work. They both get the job done. I have the same information in both of these here, right? Either way. That makes sense for using a dictionary to store. It's not we're still storing one associated value, but that associated value also is some sort of collection type, or you can have more than one thing all at once. But there's only one value associated, whether or not it's a dictionary or a list associated with it. That's a good question. All right, I'm going to commit all this to GitHub here. So here is more branching, commit, and push that out. All right. If you got other questions, thoughts, let me know. You've got lots of ways to contact me. I would recommend you don't use the Canvas messaging, because that does not go to my priority inbox, because it thinks it's spam because it actually comes from Canvas, not an email from you. So if you actually email me directly, it says, oh, I got an email from a student, that goes to my priority inbox. It shows up on my phone right away. Because Canvas messages come from Canvas and they all get filtered out because it's spam. Most of the time, Canvas is spam, I should say. So do that, or find me in Discord, call or text. That's all well and good. Okay. All right. I think we're good. I will see you on Monday then. Have a great weekend, folks. Wednesday, right? The 28th. Yep. Wednesday, 12:30 p.m. So first thing in class, we'll go over the solution on Wednesday. If you have it done on Monday, that's fantastic. You're ahead of the game, and then you can feel good about being done early. But yep, awesome.